Hey guys, how are you all? Today we are going to discuss about the ethers. Okay, we are going to discuss about the ether. Okay, so first we start with preparation of ether. Okay, the alcohol undergo the dehydration in presence of protic acid. Right, the protic acid is one is sulfuric acid, another one is phosphoric acid. The formation of the reaction product alkene or ether depends upon the reaction condition. For example, the ethanol is undergo the reaction in presence of 443 Kelvin, the reaction which is undergo the 413 Kelvin. 443 Kelvin, it is undergo the dehydration reaction, but in case of this one, this is also dehydration, but here there is a formation of ether. Okay, the formation of ether is a nucleophilic bimolecular reaction, so that is SN2, both your nucleophile and your substrate involved in the rate determining step. Okay, the rate of reaction depends upon nucleophile as well as substrate. So SN2 reaction involving attack of alcohol molecule, the protonated alcohol as indicated below. Okay, first step is protonation. First step is protonation because carbonium ion is formed. Protonation. Okay, the second step is your alcohol act as a nucleophile, so nucleophilic attack on this carbon, nucleophile. So this is nucleophile, your nucleophile attack on your carbon. Okay, then the last step is there is a deprotonation. Okay, deprotonation. Okay, the first step is protonation, second step nucleophilic attack, the third step is protonation, deprotonation. Okay, then we go to discuss the acidic dehydration of alcohol to give the alkene associated with substitution reaction to give the ether. Okay, so this method is suitable for the preparation of ether having the primary alkyl group only. Okay, primary alkyl group only, this is very important. Okay, so alkyl group should be unhindered. Okay, so the temperature kept low, so otherwise your reaction favors the formation of alkene. Okay, so what we have to do is we have to keep the unhindered. Okay, unhindered. Okay, so the alkyl group is unhindered, your alkyl group is unhindered. Okay, the say for example this is CH3 CH3, this is OH, right? This alkyl group is hindered one because it has the two alkyl group. Then there is a temperature we should keep it in the low. Okay, so the reaction follows the SN1 pathway. Okay, when alcohol secondary and tertiary, about which you learn higher classes. Okay, however, dehydration of alcohol and tertiary alcohol to give the corresponding ether is unsuccessful. The elimination is compete over the your substitution. Okay, so the consequence, it is going to form the alkene easily formation. Okay, so if I am taking the primary alcohol at the time, we have to keep the temperature low. Okay, if I am taking the secondary alcohol and tertiary alcohol at the time, there is a hindered alkyl group, right? As I told you already here. Okay, so it undergo the elimination over the substitution. So your elimination is predominant. Okay, the next reaction, that is most important reaction, Williams synthesis. Okay, it is an important laboratory method for the preparation of symmetrical and unsymmetrical ether. In this method, an alkyl halide is allowed to react with sodium alkoxide. So your alkyl halide react with your alkoxide. Okay, so there is a formation of ether. Okay, this reaction is SN2. Okay, so the rate of reaction depends upon alkyl halide as well as your alkoxide. Okay, so ether containing the substituted alkyl group may be prepared by this method. Okay, so the reaction involves SN2 attack of alkoxide on primary alkyl halide. Okay, so look here there is a primary alkyl halide. Okay, here there is a tertiary alkyl halide. If I take the primary alkyl halide, if I am taking the primary alkyl halide, your ions forming here, right? Okay, your alkoxide is there, right? Your alkoxide, this is alkoxide, right? This alkoxide act as a nucleophile. But in case if I am taking the secondary or tertiary alkyl halide, your tertiary alkyl halide, at the time your alkoxide act as a base. Okay, your alkoxide act as a nucleophile. At the time substitution reaction, ether is formed. Okay, there is a substitution reaction. In case of your alkoxide act as a base, at the time there is a elimination reaction. Clear? So at the time your product is going to be alkene, right? So if I am taking the secondary and tertiary alkyl halide, your elimination reaction is compete over your substitution reaction. Okay, clear? Right. So here your alkyl halide here. Okay, so here alkyl halide is there. Okay, so here the substitution reaction is not possible. This reaction won't happen. But in case this product, if you want this product, okay, at the time we should take the tertiary alkoxide and alkyl halide. Okay, so we will get the ether. Clear? Right. So next I am taking the alcohol. Okay, so this I am converted into alkoxide, now alkyl halide. So alkyl halide, alkoxide react together, there is formation of ether. Clear? Okay. Next we are comparing the boiling and melting point of here. Okay, the CO bond in ether are polar, thus ether have net dipole moment. The weak polarity of ether do not appreciably affect their boiling point. Okay, which are comparable to the other alkane of comparable molecular mass. Okay, but much lower than the boiling point of the alcohol. So if you compare the alkane, okay, and ether, it has the comparable molecular mass, but if you are comparing with the alcohol, at the time it is not going to be that much. Okay, because your alcohol is more boiling point compared to your ether. Okay, the large difference in boiling point in alcohol, ether is the presence of hydrogen bonding in the alcohol. So the miscibility of ether with water resemble those alcohols of same molecular mass. Both ethoxyethane and butane 1-ol are miscible to almost same extent respectively. Okay, so if I am taking the 100 ml of water, in that 100 ml of water, okay, your ether can miscible up to 7.5 gram, your alcohol mix up to 9 gram. Okay, up to 9 gram. So this is due to fact that just like that alcohol, oxygen of ether can form the hydrogen bond. This is very important. Okay, this is very important. Hydrogen bond is formed, but that much it is not that much strong in as in case of the alcohol. Okay, this is important. Okay, they will ask in a twisted way. Then there is a cleavage of bond, okay, taking place according to what the kind of carbocation which is formed. Okay, so ether are least reactive of functional group. Okay, the cleavage of CO bond, okay, in ether take place under the drastic condition with the excess of hydrogen halide. This is very important. Okay, so if excess of hydrogen halide is there, then only there is a cleavage of carbon oxygen bond is take place. Okay, then aryl alkyl halide, okay, cleaved at alkyl oxygen, okay, bond due to more stability of aryl oxygen bond. Okay, so the reaction is yielded like this. Say for example, here there is a 2 fragment is possible. So there is a aryl oxy also possible, there is a alkoxy also possible. As we discussed, this aryl oxy is more stable. Compared to your alkoxy, because this is resonance stabilized. Okay, your aryl oxy is more stable because that is resonance stabilized, so it get easily proton from your hydrogen halide become a phenol. Clear? Then here ROR is there. Okay, the ether with 2 different alkyl group also cleaved same manner. The order of reactivity of hydrogen halide as follows. So this is the order. The cleavage of ether take place with concentrated HI or HBr at high temperature. Okay, next here is the cleavage of reaction. Okay, so the reaction of an ether with concentrated HI start with protonation of ether. Okay, so there is a first step, protonation. Okay, then the reaction take place HBr HI because of this reagent are sufficiently acidic. Okay, then step 2, the iodide is a good nucleophile. It attack the least substituted carbon of oxonium ion formed in the step 1. and displace an alcohol molecule by SN2 mechanism. Thus, in the cleavage of mixed ether with two different alkyl group, the alcohol and alkyl iodide and depends upon the nature of the alkyl group. Okay. So when primary or secondary alkyl group are present, it is lower alkyl group. Okay. It is the lower alkyl group that forms the alkyl iodide. Okay. Right. So in this, your CH3, okay, join with high, there is a formation of CH3I. Your CH3CH2 join with your hydrogen, it form the alcohol. Okay, in the step 3, the alcohol which is formed, right, that is again react with HI. Okay, then at final there is a formation of your ethyl iodide. Okay. However, when one of the alkyl group is tertiary group and the halide formed in is tertiary halide, it is because its step 2 reaction, departure of leaving group, CH3OH create the more stable carbocation. So the reaction follows the SN1 mechanism. This is more important. Okay. So in case of anisole and methyl phenol oxonium ion formed by the protonation of ether, the bond between the OCH3 is weaker. Okay, then bond between OC6H5 because of carbon phenyl group sp2 hybridized. So there is a partial double bond. So before the attack of I minus, the break of OCH3 bond form and CH3I. Phenol do not react further to give the halide because the sp2 hybridized carbon atom of your phenyl cannot undergo the nucleophilic substitution reaction. The reaction needed to convert the halide. Okay. So here first there is a methyl group is there. Here there is a one what we call it as secondary butyl group is there. Okay, secondary butyl group, pentyl group is there. So this side propyl group is there, this side tertiary pentyl group is there. Okay, so this side benzyl, this is phenyl. Okay, so here your tertiary is more carbocation is more stable compared to your primary. So this carbocation join with I, it form the tertiary alkyl halide. Okay, so this join with hydrogen, it form the alcohol. Okay, in case of this one, we know that, right, your benzyl carbocation, okay, and your phenoxide ion or phenyl carbocation. Your phenyl carbocation is less stable compared to your benzyl carbocation. So benzyl carbocation join with I, there is a formation of your benzyl halide. Clear? So here in case of the CH2CH3, okay, which is combined with iodine, it form the ethyl iodide. This form the alcohol. Clear? So then there is a electrophilic substitution reaction is there. Okay. So we know that, right, this OR. Okay. So before moving to electrophilic substitution reaction, I want to explain some detailed way the cleavage of CO bond in ether in presence of your hydrogen halide. Okay. Look here. Let's take the example of two alkyl group. So this is secondary, this is primary. Let's take the example of one more. This is tertiary, this is primary alkyl. Okay, let's take the one more example. So one alkyl is there, one aryl is there. Okay, so in this case, your secondary carbocation is more stable compared to your primary carbocation. Your tertiary carbocation is more stable compared to your primary carbocation. Again, your aryl carbocation is less stable compared to your alkyl carbocation. Okay, so wherever the your carbocation is stable, okay, there only your halide going to bond with. Okay, this is more important. Okay, so there is a many questions which is come from this. Okay, if you are studying for the board exam or NEET exam or whatever the JEE mains exam. Okay, so right. So electrophilic substitution reaction I will explain in the brief detail. Okay, so this is your benzene. In that there is a alkoxy there. Okay, here there is a lone pair of electron over the oxygen. This is involved in the resonance at the time. ortho and para group, para position, the electron density increases. Okay, so this OR is activating group. The activating group increase the electron density in ortho para position. So your product going to be your halogenation ortho para product. Your methylation, Friedel graft methylation, we are using the carbon disulfide. This is whether it's a non-polar solvent or polar solvent. Can you comment it? Okay. Next it is undergo the acylation, so ortho para product. Next it is undergo the nitration, again it is ortho para product. Okay. Then there is a question which is there, 7.10. Okay, I will explain to you. Okay. So look here, 7.6, right? Right. So write the reaction of Williamson synthesis, 2-ethoxy, 3-methyl pentane, starting with ethanol and 3-methyl pentane 2-1. Okay. So just write the product. Okay. So pentane, right? So first write the 5 carbon. Okay. So 5 carbon I wrote. Then you give the number 1, 2, 3, 4, 5. Okay. In the second position there is a O which is there. Third position there is a CH3 is there. Okay, right? So then this is one of the reactant, right? I will write the product, that is more important. I will tell you why. So your product is again pentane. Okay, again pentane. Third position your methyl is there. In second position there is a ethoxy. There is a ethoxy. Now this is your, if I break here, this is become a secondary, this become a alkoxide, this become a alkoxide. Again if I breaking here, at the time this become a primary. Okay, this is become a your whole alkoxide, whole alkoxide. Now so what I am doing is, I am going to do is, here the halide I am going to join with, halide I am going to join with. Okay, so here it become a alkoxide, this become a alkoxide. So this molecule I will take, it will react with NaOH, it form the alkoxide. Okay, then one more reactant is ethanol, it is react with your PCl3, it is going to form the ethyl chloride, it is going to form the ethyl chloride. So this is alkyl halide, this is alkoxide, react together, form the product. Okay, understood. Next we go for the, next I go for the, which of the following, okay, combination is which going to form the 1-methoxy 4-nitrobenzene, 1-methoxy 4-nitrobenzene. Obviously both, okay, might be look like it form, but this is more favorable. Okay, so this Na and Br, okay, get eliminated as NaBr. Okay, so then the formation of product is OCH3 and NO2. Okay, clear? Right. Next we go for the one more question. Look here. Here there is a breaking going to be here. This here it is Br. Here it is a hydrogen. Okay, so it is going to be your propanol and methyl bromide. Okay, so then here also there is a phenol. We know that, right? So here the phenoxyene is more stable. So then your ethyl halide, okay, ethyl iodide. Then there is a nitration, right? So ortho and para product we will get it. Then here in case of this is tertiary, so this side iodine will join. Okay, here the hydrogen will join. Okay, so your ethanol plus your tertiary alkyl iodide. Okay, so thank you all. Do well in exam. Okay, so still you have a doubt in the ether react with HI. Okay, just to comment it, I will make separate video for that. Okay, so do well in exam. All the best. Thank you.